Don't panic, because once you simplify the integrand, this whole integral would be much easier to solve. Starting from the lower limit, or a, we have this infinite series of I pi raised to the power of n all over n factorial. Well, this infinite series actually converges to -1, and since the lower limit also asks us to add it by +1, -1 plus +1 is equals to 0. This one is very straightforward. Though this may look complicated, but it's actually a very interesting expansion of pi all over 2. So therefore, the upper limit, or b, simplifies to pi all over 2. If you're familiar with the Maclaurin series, you would know this is also pretty straightforward, because the Maclaurin series of this defines the cosine function, and since the expression puts the exponent -1, it tells us to take the reciprocal of cosine of x, which is the second function, or second x. And also, this is another Maclaurin series of a trigonometric function, which is the sine of x. Pretty straightforward as well. This is the funniest part about the video, because overall this expression isn't really going to be important in our calculation, because this entire expression is equals to 1, and any number raised to the power of 1 is still the same number, still the same no matter what. Like 1, 2, 3 raised to the power of 1 is still the same number, so this isn't going to be an important part of the integrand. So this is what the integral actually looks like. And over here, we can go ahead and simplify the integrand. So second x multiplied by sine of x, we can consider that as tangent of x all over second squared of x all over tangent of x. And then that's also equals to tangent squared x all over second squared x. And of course, expanding that further, we have sine squared x all over cosine squared x all over 1 all over cosine squared of x. And that's just simplifies to sine squared of x. And the integral turns into the integral from 0 to pi all over 2 sine squared of x. And then with respect to x. And then we can go ahead and use the identity over here. So as we all know, sine squared of x, we can use the identity 1 minus cosine of 2x all over 2. We can go ahead and use this identity over here for our integral. So we can go ahead, continue. We can continue from here. So we got 0 to pi all over 2, 1 minus cosine 2x all over 2 dx is equals to pi all over 2 minus sine 2x all over 4. Go ahead. Alright, and then substituting that using the fundamental theorem of calculus, we can go ahead and that basically becomes pi all over 4 minus 0, and overall the final integral will become pi all over 4. And that is our definite integral, pi all over 4.